In this video, we will discuss chapter 6 triangles and its properties. It's an introduction video of the properties of triangles. So what is a triangle? Okay, let us move on to the video. A triangle is a three-sided polygon. And classification of triangles. Triangles can be classified based on sides as well as angles. Now, based on angles, a triangle with all angles acute is called acute angled triangle. A triangle with one obtuse angle is called obtuse angled triangle, and a triangle with one right angle is called right angled triangle. This you have already learned in smaller classes. Just a recap only, as it's an introduction video. I included the basic properties of what's triangle and all. So next, move on to classification of triangle based on sides. A triangle with all sides equal is equilateral triangle. A triangle with only two sides equal is isosceles triangle. And a triangle with no sides equal is called scalene triangle. Next, identify triangles. How you identify triangle based on both sides and angles. Let us see. Here, this is an obtuse triangle and the three sides are different. So, it's a scalene also and it's obtuse also. So, it's a scalene obtuse angled triangle. And this is a right angle triangle and two sides equal. The base and height are equal. So, what we can call it? Yes, it is isosceles right angled triangle. And this is an obtuse, acute angle triangle, but all the sides are different. So, it's scalene acute angled triangle. Next, let us see what type of triangle it is. It's again acute angle triangle, but two sides equal. So, isosceles acute angled triangle. Now, it's an obtuse triangle, but two sides equal. So, isosceles obtuse angled triangle. Now, please note that equilateral triangle cannot be obtuse or right angle. Each angle in an equilateral triangle is 60 degrees. There cannot be two obtuse angles in a triangle. There cannot be two right angles in a triangle. If a right angle triangle is isosceles, that means like this, two sides equal, then the other two angles, that is these two angles, will be 45 degrees each. This just remember. Now next, let us move on to another important topic, median of a triangle. Median. What's the median? Median of a triangle is the line segment joining the vertex to midpoint of opposite side. Once again, median of a triangle is the line segment joining the vertex to the midpoint of opposite side. So let us see. So it's a triangle ABC. So from the vertex A to the midpoint of opposite side BC. BC is the opposite side of angle A or this vertex A. So from that vertex A, let us draw a line segment to meet the midpoint of BC. Yes, AD. This is the median. Similarly, from B to midpoint of AC, that is BE, from C to the midpoint of AB, CF. So AD, BE, CF are the medians of this triangle ABC. Now let us see the medians of an obtuse angle triangle. Yes, AD, BE, CF, and for a right angle triangle, yes, AD, BE and CF are the medians. Now, the three median you can see meeting at a common point. What we call that point? The point of intersection of all three medians of a triangle is called centroid of the triangle. It's called centroid of the triangle. The middle point, centroid of the triangle. All three medians of a triangle is inside the triangle. They all lie inside the triangle. That also an important fact you have to remember. Next, we will learn what is altitude of a triangle. Altitude means height. Altitude or height of a triangle is the perpendicular distance from a vertex to the opposite side. Perpendicular distance. So let us see. It's a triangle ABC. So from A to BC, not to the midpoint of BC, it's the straight line down from A to perpendicular line from A to BC, 90-degree line. So AD is the height or altitude. AD is not the median. D is not the midpoint of BC. Okay. Now B to AC also we can draw the perpendicular 90-degree line from C to AB. So AD, BE, CF are altitudes of this triangle ABC. Now let us see which are the altitudes of a right angled triangle. So right angle triangle ABC. So from A to opposite side BC, A to BC perpendicular line. Do you need to draw it? It's already there, no? 90-degree you can see. It's 90-degree, no, here. So that means AB itself is the altitude, is it? Yes, AB itself is the altitude. Now B to AC, 90-degree. What about C to AB? CB itself. So that means two of the altitudes of a right angle triangle are the two sides itself. The base and heights are the altitudes of a right angle triangle. Clear it? Next one, let us see altitude of an obtuse angled triangle, how it comes. So one obtuse angle triangle. Now first from A to perpendicular to the opposite side BC. So let us draw the perpendicular from A. So BC has to be extended to the left to meet the perpendicular, is it? So let us extend BC to the left. Yes. So AD is the perpendicular. AD is the altitude from A to BC, and you can see that altitude is lying exterior of the triangle, outside the triangle. Now from B to AC. Yes, we got BE. Now from C to AB, how we will draw the perpendicular? We first need to extend the side AB. Now draw the 90-degree. So what did you see here? Two of these altitudes lies in the exterior of the triangle, is it? So altitudes of an equilateral triangle, let us see now. Equilateral triangle, let us draw the altitudes. AD, BE, CF, altitudes. But you observe it. What can you see? This AD, BE, CF are median also. That means D is the midpoint, E is the midpoint, F is the midpoint. That means the altitude itself is the median too. That means median and altitude are the same line segments. They coincide. Now altitude of an isosceles triangle, let us see. Isosceles triangle means what? Two sides equal. Here AB and AC equal. So from A to BC, altitude. Now B to AC and C to AB. What did you observe here? Here AD, D is the midpoint of BC. That means AD is the altitude as well as the median. But BE and CF are not median. They are altitude only. They are altitude only. So one of the median and altitude coincide in an isosceles triangle. So our observation is in an obtuse angle triangle, two of the altitudes lie in the exterior of the triangle. In an equilateral triangle, all the three medians and altitude coincide. And in an isosceles triangle, one of the median and altitude coincides. Now, very important fact is you have to note it down. Next, angle sum property is very important property of triangle. Very simple also. Okay. What is angle sum property? We know a triangle has three sides and three angles. The sum of all the three angles of a triangle is 180 degree. 180 degree straight line, straight angle. That means angle A plus angle B plus angle C is equal to 180. There is an activity you can do. If you draw a triangle and if you cut this angle portion, this three angle portion you cut, and when you arrange it, you will get a straight line. Try it. Next, exterior angle property of a triangle. So we know a triangle has three angles. These three angles are interior angles. Angles means usually we refer interior angles only. But when we extend each side, we will get exterior angle also. So let us extend the sides. BC extended, CA extended and AB extended. So now we got three exterior angle adjacent to the interior angles. Now what this exterior angle property? Now I am naming the interior angles are ABC I am naming, and exterior angles let us name as DEF for our convenience to refer. Okay. Now exterior angle is equal to sum of interior opposite angle. So you should understand what is this interior opposite angles. For example, if you consider the exterior angle F, C is its adjacent interior angle, nearby, its pair. But A and B they are interior but opposite. Interior but opposite. So for this exterior angle F, A and B are interior opposite angle. What about D? For D, A is the adjacent interior angle. So which are the interior opposite angles? B and C. Similarly for E, B is the adjacent interior angle, nearby. So A and C will be the interior opposite angles. So what this property says? Let us see. Angle F equal to sum of interior opposite angles, that is A plus B, angle A plus angle B. Similarly, angle D equal to angle B plus angle C, and angle E equal to angle A plus angle C. Clear? And one more important thing you can notice here, if you take one exterior angle and its nearby interior angle, they form a linear pair. See here, they form a linear pair. That is, interior angle and its adjacent exterior angle form linear pair, that is angle A plus angle D180, angle B plus angle E180, and angle C plus angle F equal to 180 degree. Clear? Next one, equilateral and isosceles triangles. You already know what is equilateral and isosceles triangle, but let us say a little more properties about them. All sides equal, that is the equilateral triangle, all sides as well as all angles equal, that is equilateral triangle. And I mentioned that all the angles, each angle of an equilateral triangle is 60 degree. All are 60 degree. And in an equilateral triangle, all sides are all angle equal and each angle 60 degree, and all the medians and altitude coincide. Now let us see about isosceles triangle. Isosceles triangle, one of the median and altitude coincide. And not only that, here AB and AC equal. So when two sides equal, angle opposite to the equal side, that is AB, which angle lies opposite to the side AB? Angle opposite to, facing AB is opposite C. Angle C is opposite to angle AB. Angle B is opposite to side AC, and angle A is opposite to side BC. So here AB and AC equal. So the angle opposite to the equal side, that is C and B, they also will be equal, and we call them base angles of this isosceles triangles. Which two sides are equal? The angles opposite to those sides also will be equal, and one of the median and altitude coincide. Next, relation between length of sides of a triangle. With any measure you can, any three measures or any three length of line segment, you cannot draw a triangle. There is a particular measures are there. The measurement should be up to this, between this like that. Then only you can draw a triangle. Let us see. Here ABC is a triangle, and let us see. Let us assume that side AB is A unit, side BC is B unit, side AC is C unit. In any triangle, sum of the two sides, sum of the two sides is greater than the third side. Otherwise, the triangle is not possible. That means, if you take the sum of sides A and B, length A and B, A plus B, sum of the two sides should be greater than third side. That is A plus B greater than C. And if you take the side B and C, B plus C greater than A, and A plus C greater than B. Any two side sum should be greater than the third side. Then only you can draw the triangle. Let us take an example. If A equal to 3, B equal to 5, C equal to 8. So A plus B is what? 3 plus 5, 8. Which is the same as the third side, not greater than, is it? It is same as the third side. So you cannot draw the triangle. If you want, you try. You cannot draw the triangle. The sum of two sides should be greater than the third side. So the third side, what can be the measures? C should be greater than, see, 5 minus 3, 2. So the C should be greater than 2 and it should be less than 8. It should be greater than the difference between other two sides and less than the sum of the other two sides. Note down this point. Next one. Very, very, very important property of a triangle and is the most beautiful theorem, beautiful property of triangles. Right angle triangle and Pythagoras property. Right angle triangle, one angle 90 degree, and here the side opposite to the right angle, that is side opposite to B is the right angle here. So side opposite to that is AC. The side opposite to the right angle is called hypotenuse. What we call it? Hypotenuse. Other two sides, we call them base and height, or you can simply call them legs. They too are legs of this right angle triangle. So hypotenuse, then two legs, or hypotenuse, base and height. Now Pythagoras property. What is Pythagoras property? Very important definition. In a right angle triangle, the square on the hypotenuse equal to sum of the squares on the legs. That means AC square. Square means what? AC into AC. Because you haven't learned exponents, so you won't understand what is this square. Square means if you are multiplying a number with the same number 2 times, AC into AC, that is AC square. Okay. So AC square is equal to AB square plus BC square. That means hypotenuse square is equal to sum of squares of other two legs, that is height square, base square plus height square. Hypotenuse square equal to base square plus height square. Now let us verify this property. How? Let us see. That is, Pythagoras property states that the area of square on the hypotenuse equal to sum of the areas of squares on the legs. So let us see. Right angle triangle. So let us draw squares on all the three sides as hypotenuse. So that hypotenuse as side we will draw one square. Then each legs as side we will draw 2 more squares. Let us see. Like this. And these measures of the sides of these squares are given. So what the property says? Square on the hypotenuse. So what is the square area of this square A? Area of square A, side into side. Is it 5 into 5, 25 square centimeter? Area of square B, 4 into 4, 16 square centimeter. Area of square C, 3 into 3, 9 square centimeters. So as per this property, area of square A equal to area of square B plus area of square C. So let us see. 25 equal to 16 into 9. Yes, that means A square. A square is equal to B square plus C square. So this is what mentioned, these things, these all properties are mentioned in the chapter. And next video we will go through the exercise questions of this chapter. I hope you understand now what is triangle, different type of triangles, their properties. So go through this video, learn, understand them properly. And because these properties, these concepts are very, very important in higher classes. So best wishes. Thank you.